Okay, so students sometimes have a hard time graphing using the MyMathLab Graphing tool for Lesson 17. So I'm going to go through and make sure that you know how to use that. So on this problem, we're working on number 3. We have h of x is equal to 5 to the x plus 2, then minus 5. So I really should have put h of x here instead of y. So on my scratch paper, I write it down. I'm thinking, do I have any horizontal shift? Well, the horizontal shift is up here in the exponent with the parentheses, and that says plus 2, so that's actually going to be opposite of what I think. It's going to be a left 2 in the horizontal direction, so I'm going to write negative 2 for the horizontal. The vertical is the one outside of the parentheses, outside of the exponent, and that's exactly what you think it is, down 5 or negative 5. Notice the horizontal one is opposite, but the vertical one is not. There is no compressor stretch, so I'm going to put a 1 there, or you just know that there is no compressor stretch. And that's because there's no number being multiplied in front. Oops. Like there's a 1 times there. And no one usually puts 1 times. I'm going to go ahead and undo that. A compressor stretch would be like in the next problem that I'm going to show you, where you have this 1/7 times 2 to the x. Notice 2 to the x is the exponent. The 1/7 in front, that is the compressor stretch. So clearly on the blue problem that we were working on, it doesn't have any. So I have a horizontal shift, a vertical shift, and no stretch or compress. So then I'm going to come over here to the graph. I'm going to enlarge it just so you can see it a bit bigger here, and move it over a bit. Come on, there we go. Okay, so the question says use the transformation of this graph f of x equals 5 to the x to graph the function h of x given below, this one down here. Notice that we have to graph the function, we have to graph and give the equation of the asymptote, so we have to graph the asymptote. That's one thing that students often get don't understand why they're missing points on, because they forget to graph the asymptote. And then we're going to have to find the domain and range. So let's first graph it. So over here I have the exponential tool right here that hasn't shown up in the past, but now that we're working with exponential functions, it's right there. So you're going to go ahead and click it. And I always start here at 0, 1 because I know every exponential goes through 0, 1 before we get shifting and compressing and stretching. So there's my basic graph of 5 to the x. Notice it automatically put in the 5 for you, okay? See, it says the base is 5. Now, if this problem was a 2 to the x, it would automatically do that for you. So that's actually kind of nice that it already does that part for you. What you're really concerned about now is the shifting. We said our horizontal shift was a negative 2. We've already talked about that. So I'm just going to go ahead and plug in negative 2 there. Notice that automatically my graph shifted left 2. And my vertical shift, I believe we said was negative 5. And you click off that, and then now it shifts down 5. So if I go ahead and save that, that would be a nice graph of this h of x. If you hit check answer, it's not going to give you all your points because you didn't graph the asymptote. So we're going to go back in, we're going to click on that again and make it a little bit bigger. And then to graph the asymptote, I want a dotted line. So right here, do you see how I went from solid to dotted? I know it's a straight line, so I'm going to use a straight line tool with the dotted already clicked. And it's at y equals 5, negative 5. So just pick 2 points along that line, and it creates that new orange line. Once I save it, it comes blue on my actual picture. If I want to blow that up a bit, you can see that a little better. Okay. So now that I believe I have graphed it, and I've graphed the asymptote with a dashed line, now I think I'm going to go ahead and check my answer. Good job. What is the equation of the asymptote? We already said that was y equals negative 5 because it's a horizontal line. Good job. The domain of all exponentials is all reals. So we're just going to go ahead and do negative infinity. And then click over into the other blue box, maybe arrow over, and then do infinity there. Okay, So I hit OK, and yay, I got that right. Now the range doesn't go all reals. It doesn't go down forever. So the lowest I could have is -5. In fact, I can't actually have -5. I can't include it, so I'm going to use the open. The parentheses for the open circle. So we have -5 is as low as I can go, and I'm going to arrow over and do infinity. Let's check that, and I am good. Okay, so I'm going to do one more problem with a compressor stretch. Let's pull up my graph here, my scratch paper. So on this problem, I have no horizontal shifts. I did not spell that right. Horizontal shift. So I don't have a horizontal shift, I don't have a vertical shift. My compress and stretch, I do have a compressor stretch. In this case, it's a compress because 1/7 is less than 1. So that's the information that I'm going to need. So I'm going to pop back over to my question, make that a little bit bigger here. Okay, so I'm going to use my exponential tool, and I'm going to click on 0, 1, because I know that all exponentials go through 0, 1. Notice that my graph had a base of 2 to the x, and it already has a base of 2, which is pretty nice here. So all I need to focus on is the horizontal shift, the vertical shift, and the compressor stretch. So I have no horizontal shift, so I'm going to leave that 0. No vertical shift, I'm going to leave that 0. But I'm going to change this vertical stretch and compress to 1/7. Please note that there is such thing as a horizontal stretch or compress, but we're not actually doing that until pre-cal, so please don't don't type anything into this horizontal stretch or compress in this class. So take a look at this orange line. It's going to shrink once I click off of this. Nope, there it went, and it shrunk. Okay, so I'm going to go ahead and save, but then I'm going to go right back into it because I would like to graph my asymptote. So my asymptote needs to be a dotted line. So I'm going to go ahead and click the dotted line tool. It's a straight line, so I'm going to go ahead and use the line tool. And I know that my asymptote is at the x-axis because I haven't shifted vertically at all, so I know that that's going to stay put. So go ahead and do that. Hit save, and now I have a dotted line here on the x-axis, and this graph of 1/7 times 2 to the x is going to be approaching that asymptote. Let's go ahead and check my answer. My equation of the asymptote is just going to be y equals 0. That's the x-axis, y equals 0. Notice that all of the x's can be whatever they want to be, but the y's have to stay constant at 0. And what is the domain? We said the domain is going to be all reals for all exponentials. So -infinity to +infinity. But the range is not going to be all reals. As low as it can go is 0, but it can't actually include 0. All the way up to infinity, so the range is going to be, use the parentheses because I can't include 0, so I'm going to use the parentheses there. Comma, infinity. Go ahead and check that answer, and we are done. I hope this little tutorial helped you use this graphing tool a little bit better.